Hi Rivej, I see you have a project to share with us. Can you share or talk about your journey? I have been fascinated by robots, and when I decided to take on the challenge of building a self-balancing robot, I thought it would be the perfect project for the school science fair. I imagined it gliding across the floor, effortlessly standing upright and impressing everyone with my engineering skills. What I didn't expect was the frustration, confusion, and the setbacks I've been facing along the way. The journey began with an excitement as I gathered all the parts: motors, batteries, Arduino, Uno, uh, wheels, switches, and all the wires. I knew the basic principles. Use the sensors to tilt, adjust the motors to maintain balance, but when it came on putting all the pieces together, things did not go as smoothly as I hoped. I spent days trying to get the robot to balance, but every time I powered it on, it would either fall forward or backward, completely ignoring the adjustments I had programmed. I checked the wiring, recalculated the sensors, and re-uploaded the codes countless times, but nothing seemed to work. I realized that even with the best sensors in the motors, balancing was not as simple as I imagined. One of the biggest issues was the control system. My PID algorithm wasn't responding quickly enough to tilt the data. The robot would start to lead, but by the time it made a correction, it would already fallen over. I read dozens of articles, watched tutorials, and tried different approaches, but each attempt ended with the same result: a toppled robot. By the time the science fair had rolled around, my robot still couldn't balance. I showed up at the event with a prototype that, while interestingly, was a far cry from the sleek functional design I had envisioned. Instead of presenting a perfect balancing robot, I had a collection of notes, sketches, and a series of failures. But in a way, I felt a sense of pride. I had learned so much more about robotics and the challenges engineers face when building complex systems. It wasn't the success I had hoped for, but it was a stepping stone, one that would guide me through the future projects. As I watched other students presenting their projects, I realized that failure was just another part of the learning process. It wasn't the end of my robotic journey, but just the beginning of many more attempts. I might not have built a self-balancing robot this time, but I am determined to try again, this time armed with more knowledge and experience. What is your project called? The self-balancing robot. The robot was designed with gyroscopic and accelerometer sensors that constantly measure its tilt and adjust its movements. These sensors fed real-time data to the onboard processor, which made split-second decisions about how to shift its weight to maintain balance. By using two wheels and carefully calculated movements, the robot could roll around smoothly, even on uneven surfaces. What are its basic components? A self-balancing robot is a machine designed to maintain its upright position without external support. It uses sensors and motors to stay balanced on two wheels, much like a Segway or a balancing scooter. The main components include motors, MPU 6050 sensor, and Arduino Uno. How does it work? The robot uses feedback from the gyroscopic and accelerometer sensors to monitor its orientation. If it starts to tilt too far, the controller adjusts the motors to correct its position. Oh, is it? From where does it get the feedback from? A common technique is the PID control algorithm, which helps the robot make smooth and accurate corrections to stay balanced. Where are they used? Self-balancing robots have applications in personal transport like hoverboards and segways, delivery systems, and robotic research. I see it has been an incredible journey for you. We wish you luck for your future projects.